We have the data calculated in the previous unit, the curvature and profiles, axes and cross profiles, and we are now going to proceed with how to calculate the volume of earthworks with our data, for which we use the surfaces we calculated in the previous measurements and the cross-section profile files, taking into account that the calculations should always be conducted using the same. Well, we will first calculate the volume by cross-section profile difference by going to MDT, Volumes, Cross-section difference, and selecting the old quarry file first, followed by the current quarry file. The following options will enable us to define the volume interval by pKs. We can also use a standard or a crude list and a calculation method generally by average area, which is the procedure for cross-section profiles. With regard to slopes, we generally use vertical alignments or define a slope value, meaning that when one cross-section is shorter than another, we can use one of the vertical alignments to calculate the volume or prolong them with a specific slope. Finally, we can also define other parameters, such as the case of topsoil or sponge, and compaction factors in relation to the earth. In the volume interval, we can also define the pKs for which we are not interested in calculating the volume, as well as any island or section we need to keep in accordance with the case. We now accept, and the program begins to calculate, obtaining a complete list of volumes defined by the pK, the clearing and embankment surfaces where applicable, a plant surface if we have applied a layer of topsoil, and the volumes of clearing, embankments, and plants. The final and pKx/pK results appear at the bottom of the screen, and there is also the option of obtaining an accrued list. We can print the results on the printer as an XML, Word, Excel file or files, or by drawing or using an Acrobat PDF. The result is diverse, and in this case, we print on the sketch screen. We also select to draw our files or our cross-section profiles with their difference, and we draw both sets of data with the designated parameters. Once the profiles have been drawn, we can see the data we have been able to draw, such as the terrain line, of course, the height and terrain data, the slope height for the seconds profile, cut number, and pKs. Let us see what we were referring to in relation to calculating the vertical cuts or prolonging. In this case here, we have a cross-section that is shorter than another that does not cut. The program will calculate a straight cut by default, but we can also assign a specific inclination to the slope that also prolongs or cuts them. We now return to MDT, Volumes, Cross-sections difference, and select the files again. The central option, under Slopes, enables us to define cleared and filled-in slopes, which does not prolong the ends or with a cut code.